Hi everybody. Today we're going to look at the graphs of a sine curve, a cosine curve, and I will show you real quick a tangent curve. And when you are looking at these graphs, you are looking at the angle in radians as your input, and the output would either be the sine, the cosine, or the tangent of that particular angle. So starting with the sine, your input is the angle, and then your output is sine, which means your output pertains to the y value. So if you think of 0 radians, your y value is 0. If you go up to pi over 2, up, your input is pi over 2, and your y value is 1. If you go over to pi, your input is pi, your output is a y value of 0. And then if you go down to 3 pi over 2, your input is that 3 pi over 2 radian angle, and then your y value is -1, and you're going to go back to 360 degrees or 2 pi radians and back to where you started, and then you're going to have a y value of 0, and then it's just going to go over and over and over again. So watch what that looks like here. And all of these are periodic, so they would continue in both directions. Alright, so I'm going to pause that and us go somewhere else. Escape, that wasn't a very good large view. Alright, the cosine curve, I have a lot of lag time here, so try to bear with me as I work these out. Alright, now I want to show you the cosine curve. This particular video drives me a little bit crazy because she is saying cos instead of cosine. It'd be really great if you came up. Alright, so let's take a look at this one.
Cos x, our definition of cos in the unit circle, remembering that it's all to do with the x coordinate of the point on the unit circle, and watching that green line we see how the value of cos changes as theta changes. And now if we use that definition to create our graph, we see that cos starts out at 1, decreases down to 0, out to -1, increases back to 0, and then back out to 1. And again we have the same situation with the sine curve. We could lap around again and see this exact same pattern occur again. We could have gone in a clockwise direction from the positive x-axis and looked at the part of the graph to the left of the y-axis. And so we generate this cos function. Again, it's periodic. We only need to look at a span of 2 pi units to see the entire shape, and we could then repeat that again and again and again. So it's periodic with a period of 2 pi. It's also an oscillating function, and it also oscillates only 1 unit above and 1 unit below. So it has what we call amplitude of 1. You'll notice that the graph of y equals cos x is very similar to the graph of y equals sin x. In fact, it's exactly the same. There's just a translation involved here. So all we would need to do is take this graph and translate it to the right or to the left, to the right by pi on 2, and we would have the graph of y equals sin x. If we translated to the left by pi on 2, it would be negative sin x. And so both graphically and in the unit circle, there's a whole lot of symmetry going on between sine and cos, and a whole lot of relationships between those, and we'll look further at that a little later on.
Okay, so I wanted to take a look at this in an application called Desmos. So she had mentioned the amplitude. So the amplitude is going to pertain to this A value here, and if A gets bigger, hopefully this works. When A gets bigger, you can see that there's a vertical stretch here, and now instead of going up to 1, it's going up to 3.2. I have a little bit of a lag time, so kind of bear with me. So this is an amplitude of 5, and here, if I go down, it's going to flatten it. I think. Let's see. so that didn't work. What's going to flatten it is a decimal. So, sorry. So if I look here, that's what I was looking for. So the 0.4, and it gets a lot flatter. These are called sliders. So they're just looking below instead of above. So it's really kind of the absolute value. And if you look here, what has happened is because it's negative is we have a reflection. So if you look at the 0, instead of going up first, it's going down first. So that's because it's a reflection. All right, I'm going to put this one back to 1. I think I can maybe do that easier by typing it in. Okay, and then the D value, anytime we add or subtract something, you might want to guess to yourself, what do you think is going to happen with the graph? We'll watch. Oh, you guessed it, right? It goes up, or it could go down. So if I do -1, it brought the whole graph down. So we call that a center line or a midline that the graph is toggling about. So that's what you're looking at. So it's not going to be 0, -2. It's actually going to be the -1. That would be your center line. Right, so I'm going to put back the 0 there. Oops, I'm in a subscript. So let's say equals 0. Okay, and I wanted to take a look at the B value, and B is the number of waves between 0 and 2 pi. So right now between 0 and 2 pi, because if you come over here, you're at 6.28. Clearly you can tell that the graph is so specific, insert sarcasm, but that's really kind of tricky to tell. But I want to know how many waves are there between 0 and 2 pi. So I'm going to change this to a 2. And now it's double time. So I have 1, 2 waves between 0 and 2 pi. I can change this to, you want to see it get a little crazy, I can do 4. And now I have, coming over here, I have 1, 2, 3, 4 waves between 0 and 2 pi. I'll put in a decimal if I wanted. So if I did 0.5, that's going to be half a wave between 0 and 2 pi. So from here to here. All right, the last one I wanted to just show you a quick clip was the tangent. I have a quick video of the same woman with her same accent, which is better than mine. But I will tell you that she calls it a tan instead of a tangent. It's really tangent.
So let's have a look at the graph of y equals tan x. And tan x is a little different to sine and cosine.
So remember, the tangent is the graph of y over x. So you have that a different concept here. And if you think of what that means is you're going to have some that, remember, were undefined because you're doing y over x. So if x is 0 at pi over 2 and 3 pi over 2, you're doing 1 over 0 or -1 over 0. So those are undefined. And as you go through, that's going to come out here. And you're always looking at y divided by x, which I don't know that she says, but I like the graphic. So just pay attention to the graphic.
Just to go back to our definition of tan in the unit circle, remembering it's all to do with the y coordinate of the point of tangent. So it gets larger and larger and larger, and then gets negative and back to 0. The other thing that you'll note about tangent that was quite different from sine and cos, I'm going to play that again, is that in one unit circle, from 0 to 2 pi, we essentially see the same thing happen twice. So we've seen that happen, and then it's repeated again, up, and then negative, and then back up to 0 again. So the same things occurred twice. And we'll see that in the graph when we plot out the graph from 0 to 2 pi. So it increases, 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 doesn't exist. Negative, 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 back to 0, increases, 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 doesn't exist. Negative, 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 back to 0. So the same thing occurred twice.
So what happens with the tangent?
Those points where
So what happens with the tangent versus the sine and cosine? The sine and cosine parent function both have a period of 2 pi, whereas the period of a tangent is pi. Hope this helps, guys.